When I started uni, there was a lot of excitement about the Human Genome Project. Researchers from all over the globe came together to figure out the precise molecular code that made us, us. This project took more than 10 years and cost billions of dollars. But it shed new light into human evolution. It helped doctors better understand their patients' conditions. And in some cases, it guided the development of novel therapeutics. In fact, there was so much enthusiasm and excitement about the Human Genome Project. I moved from a weird little hippie town on the coast to a comparatively big city to study things like genomics and biochemistry and molecular cell biology. Because, as a weird hippie myself, these were the skills I thought I would need if I wanted to help people. This was the things I would need to know if I wanted to make a difference. And as I went through my degree, it became clear that the Human Genome Project, while a significant achievement, didn't capture the vast number of genetic differences that made each one of us unique. Even though the cost of sequencing during my degree started to fall, it was still super expensive, and we wouldn't be sequencing anyone anytime soon. And while this was a bit sad, we had so much information and so many new ideas for research projects and therapeutics. I couldn't be sad for long. But then, something incredible happened. As I was finishing up, the cost of sequencing began to fall. New technologies were developed. And something that once cost tens of millions of dollars, over the span of 8 years, only cost thousands. Now, you can sequence your genome and figure out the specific molecular differences that make you, you, for less than the cost of a new iPhone. I think that's incredible. So with personal genome sequencing becoming practical, we started thinking about how this could be applied to health. And while so many different areas of health could benefit from genomics, the thing that really stood out to me was cancer. So just a really quick aside. You know how everything seems to cause cancer? You know, it's like everything from cigarettes to sunlight. Well, that's because cancer is a disease of the genome. It arises from damage to your DNA. So anything that damages your DNA can potentially cause cancer. We call this damage mutation. So we thought that by taking the genome of a healthy bit of tissue from someone and comparing it to the genome of a cancer cell, we could figure out the specific mutations. And from that information, we might be able to identify specific treatments that could better help people. There was a lot of excitement and enthusiasm about this. Researchers from all over Australia started to do some really fantastic work in this space. In fact, some of the largest grants in Australian history were given out to support this sort of work. And we'd get up on stages like this and we'd share our excitement and enthusiasm for the future. But as time went on, I started to notice something. When the people we cared about got sick, their treatments weren't being informed by genomics, and the differences in their DNA weren't being looked at. And I get that we can't rush medical advances and that medical ethics are incredibly important to make sure that our treatments are safe and effective. But that was really difficult for me, and I can't imagine how difficult it would have been for someone going through that process. I'd studied genomics to help people. As a weird hippie, this was something that was really important to me. And this was so difficult, especially when people who were suffering from the diseases we were looking at started contacting me, asking for help. I'd learned a lot of things in my degree, but this wasn't one of them. All I could do was listen to them and try to connect them with the specialists in their field. And while they were really rare, they were able to provide some form of solace to these people. And of course, I don't want to overlook the exceptional work that's happening all over the world in places like Australia and Finland and China and England. This work is going to be foundational for establishing clinical genomics. But I'm not going to lie, this is really hard to see. So I started thinking there had to be a way to help more and more people utilize the information in their DNA now, rather than at some distant point down the track. So I started to speak to people. I spoke to the patients, that contacted me. I spoke to scientists at the top of the field. I spoke to clinicians on the front lines. I spoke to the people selling sequences and the innovators inventing and dreaming up new solutions and the people making decisions for healthcare. And from all this information, patterns started to emerge. People know that their DNA and the information in their DNA is important. But when they go to their primary healthcare providers, like their GPs, they couldn't get any answers. Genomics is so new and so novel and so tied up with so many ethical and social and legal issues that most clinicians aren't comfortable using this data. Instead, they refer their patients onto specialists. And these specialists are phenomenal. I have never met one who isn't incredibly passionate and dedicated and incredibly clever. But there's not enough of them. And as a result, there can be incredibly long waits for patients to see someone that can help. And then when patients do see someone, genomics is so full of bizarre terms and weird concepts that it can almost seem alien. And a lot of people struggle to ingest what their genes mean for them. And this isn't unique to patients. When they go back to their primary healthcare team after seeing the specialist and look for clarification, often things were so complex that the primary healthcare team would just send them back. And maybe it's because I'm a scientist and this is how I deal with the world. But I couldn't help but to ask questions like, what could we do to help more GPs feel comfortable in utilizing genomics? And how could we help specialists see more patients? And how could we help patients understand what their DNA means for them when they're ready? Now, the thing that stood out to me about these questions was that they had answers. They didn't describe insurmountable problems. They described problems that if we could solve, we could help more people utilize the information in their DNA. So I began looking at what was out there, but after seeing and surveying the field, it became clear that we need to build something new, something that hadn't been built before. And while I use computers to make sense of DNA, I'm not a software developer. I don't have the skills to build something to the exact standards of a medical device. Likewise, as much as I love PowerPoint, I don't have the ability to design something that can convey a huge amount of information at a glance. It was clear I was going to need help. And as I spoke to other researchers, it became clear that they didn't have these skills either, and I need to look farther abroad. And as I began to speak to people, we realized that this wasn't just something that we could knock over in a weekend or over a couple of beers. This was something that would require an extended period of time of development and support to really benefit from. And this is where the first problem really emerged. When speaking to people skilled in the art of research funding, while they agreed that this work was valuable and could help a lot of people, they didn't think it was competitive. They didn't think we'd win funding. They actually suggested we go to industry for help. And as a weird hippie, I didn't know how to feel about that. Business was people who liked neckties and briefcases and maximizing profit above all else. That wasn't for me. So I started thinking, I didn't know what to do. I had to think about how we could solve this problem without making a deal with the devil. And maybe it's because in Brisbane, what really struck me when I started thinking about scientific advancements that were able to leave the lab and move into the real world, the thing that struck me was the cervical cancer vaccines. And normally when I think about these vaccines, I think about the great work that Fraser and Zhao did, exceptional researchers. But for some reason, I started thinking about the role that groups like CSL and Merck had played in taking this work to the next level. And as I stepped back and looked abroad, and started to think about things like the antiretroviral medications that have been so important in our response to COVID, I thought about how they were developed and how they've transformed the way that we think about HIV. I thought about the scientists involved, but also the commercial partners that actually got those products where they needed to go. And looking at back and looking at more and more things, I realized that everything from pregnancy tests to probiotics, all in some form relied on commercialization. So I might be a weird hippie, but maybe this is something I should at least consider. Maybe if I could harness commercialization and the systems of industry, we could build something that gets out to the people that need it. So I asked myself, if the machinery of commercialization could be adapted to the problems that mattered to me. And I don't want to overlook all the times that this machinery has done some terrible things, be it instances of greed or instances where people have exploited their position to impact vulnerable communities. But when I spoke to people in the commercial sector, what stood out to me was that these exemplars weren't indicative of their philosophy. Where I expected selfishness and greed and capitalism, instead I found a deep and sacred value for the health of their patients. So I was a bit proud of myself. I challenged a preconceived notion and I realized the world was a bit more nuanced than I first thought. But I kind of then ran into a proper roadblock. I had no idea where to start. And I wish I could say the solution to this roadblock was clever or novel or innovative. But what it really entailed was me as a researcher pulling my head out of my little research bubble and connecting with a wider world. Because it turns out that industry and government and educators had all gotten together to construct amazing programs to help teach people like me how to work with industry and how to develop skills around commercialization and business and entrepreneurship. And by developing these skills, I was able to work with industry. We were able to assemble a team of incredibly talented developers and designers and project managers. And we've been able to begin to build a product that starts to solve some of the problems I care about. Now, I would recommend anyone who has a problem to at least consider trying one of these programs, or putting your hand up at your next hackathon, or joining your local meetup. But the thing that really stands out to me about these programs were the other people in there. Again, I thought they'd be full of business guys, but they were actually full of other people starting businesses as a way to solve the problems they cared about, like poverty and food waste and climate change. This to me wasn't just inspiring because there were some exceptional people out there, but because it shows me that commercialization isn't just a solution for weird genomics projects. It's something that's applicable to more and more people with big problems. I might be a weird hippie who had some misconceptions about industry, but I know that there are people much smarter than me out there with similar hesitations. I know that a startup isn't the solution to everyone's problems. And I'm not going to stand up here and tell you that this has been easy, because it hasn't. And I'm not going to say that there have been times I thought I should resign from this spot because we've come up against huge challenges and I felt like a giant fraud. But in those staggering highs and crushing lows, what I remember is that starting my business has given me a way to begin to solve a problem I'm passionate about. And if you're out there, if you're someone with a big idea that takes on a big problem, I hope you'll at least consider using commercialization as an avenue for translation. Thank you very much.